Okay, let's talk about shunt generators. We have our armature connected in parallel with the shunt field. Now if I come along here, put my voltmeter at this location here, that can be used as the demarcation line between your generator, which is the power supply, and the load down here. If you notice, I've got 3 amp meters located here. Got the first amp meter is your total current. The second amp meter is the current that's in the shunt field. The third amp meter is our load current. Your alternator, your armature, this part of the generator provides all of the current. The current is not coming from the shunt field. Any current coming from this armature goes to the shunt field and the load. Okay? So what happens? We start off with some residual magnetism again to start this process. Okay? If we look over here, I will put this right here. Okay, we've got our north pole and our south pole. And what we have here, we have our shunt field wound around our pole pieces. Okay? Okay, we've got, before we have anything going through here, do we have no rotation? The only thing we have in there is residual magnetism, right? So residual magnetism, if we look at these pole pieces, we have just a little bit of a magnetic field through there from our residual magnetism. Okay? Now what do we need to generate current? We need a magnetic field, right? We need motion. And we need wire cutting that motion. Right? Okay. We have wire cutting that motion in the armature that's spinning, correct? Well, we've got to get it spinning first, so that's our motion. We need our magnetic field to start us off. Okay? That's our residual magnetism. Everybody with me on that?
Yes.
Okay? Now, the result is some current that comes out of this armature here. So we start spinning this up. It's sitting inside a magnetic field, residual magnetism. It generates a little bit of a voltage. When we did our series generator, we were generating what? 3 volts?
Yes.
Okay? So we generate 3 volts, and what happens to that 3 volts? Can we provide a path through this shunt field right here? It's at 3 volts in parallel with the armature, so it also gets 3 volts, right? Okay? Now our switches down here and here are open. No load current going through our loads, right?
Right.
Okay. So, all of our current is right through this path here. What happens now when I start running current through this shunt field?
It
Increases the magnetic field. Now, if I have current through this magnetic field here, through this shunt field, okay, once I start putting current through that shunt field, my magnetic field increases. If you remember in the book, we talked about amp turns. The magnetic field is proportional to your number of turns and the number of amps running through the coil, right? So if this current increases, the magnetic field is going to increase. So I'm going to go get a different color chalk here. Hopefully it'll all show up properly. And I'm going to say, now our current through that field is going to show up and start creating a stronger magnetic field. Now this armature is now seeing a stronger magnetic field. What's going to happen to my output voltage? It's going to go up. It's going to go up. Now that output voltage goes up that's applied from here to here. What's going to happen to the current through this coil here? It's going to go up again. Do you see this stepping stone process we're talking about here? So this is going to increase again. Okay? Now if our current increases, therefore our magnetic field increases again, doesn't it? Magnetic field increases that's being applied around this armature, it's going to go up again, isn't it?
Thank you.
Okay? It's going to go up again.
This is with motion of the armature or no motion yet?
Armature's spinning. The armature's spinning. We started spinning this at the very beginning. Okay? So what's happening here, we've got a residual magnetism, makes a little bit of field. We get some current through this shunt field. It increases the magnetic field. The magnetic field increases. Our output voltage increases. Okay? This is going to continue and continue and continue until we get to the point where these pole pieces are saturated. We can't cram any more magnetic flux in that area. We just can't cram any more, and it saturates out. Okay? So no matter what you do, it's not going to increase our output voltage. And what happens, these generators are designed so that it'll reach that saturation point, everything will be set up, and then now you'll be at your rated voltage. Okay? We've got a number of things that we can talk about here as far as, let's start putting some numbers on here. Okay? Let's say I've got a field resistance of 500 ohms. Okay? And we're going to talk about our output voltage. Okay? And if you remember Ohm's law, we've got E is equal to what? I times R. We're going to be using this all over the place now. Okay? So we started off with the 3 volts. Okay? We can calculate our current. I is equal to E over R, will equal to 3 over 500. Okay? We do the math on that. What is that? 6 milliamps? Okay? 6 milliamps. So now we have 6 milliamps of current going through here, and it increases our magnetic field. Okay? Let's say that magnetic field increase resulted in an output voltage of 30 volts. Okay? Now we've got 30 volts here. What's our current going through our shunt field? 60 milliamps, right? We're up to 60 milliamps. Now I've got 60 milliamps current going through there. It's going to really increase our magnetic field, isn't it? Okay? Now let's say, okay, well, what happens if we go up to, say, 100 volts output off the armature? Okay? 100 divided by 500 gives me what? About 200 milliamps? What's that?
0.2 amps or...
Yeah, 200 milliamps, right? Okay, there we have 200 milliamps already there. That 200 milliamp of current is coming from the armature and creating this magnetic field, which is then reinforcing and strengthening the magnetic field that the armature is using to generate your output voltage. Okay? Now we do one more shot and it slows down. We're at 120 volts. Okay, about what, 240 milliamps? Okay, and we're up there. Now we're saturated. It sits at its rated voltage. Okay, all of this takes place so fast, by the time the motor finishes spinning up to its rated RPM, we're at the rated voltage. The whole process goes blink an eye. It's there. Runs up, everything moves at the speed of light, and we're up to saturation. Okay? You'll see your voltage come up to speed, and typically as the RPM is increasing, the voltage is increasing. By the time the RPM gets to maximum, we're there. Okay? Now if we start the motor, okay, start the motor. We've got our residual magnetism. Okay? The whole process, we start our motor, we have our residual magnetism. We can start off with a small amount of voltage generated, right? You've got current. Your current in your shunt field increases. That results in your magnetic field increase. Okay? That results in your output voltage increases.
Say if it overloaded, which will overload, the armature or the field?
We won't get to overload yet. Okay? We won't get there yet. Okay. So, start this process. Start the motor running. The residual magnetism causes a small amount of voltage to be generated. The current in your shunt field increases. Results in the magnetic field increase. Results in your output voltage increases. Okay? Are we at rated voltage yet? Okay? Are we at our rated voltage yet? No. And we say no. Okay? This output voltage increased will cause our current to increase. That current increase will cause our output voltage to increase. And we will sit here in this circle until we reach our rated voltage. Okay? We'll know at that point the generator is saturated and we're at our output voltage. Okay? You'll have this circle. It will take place almost instantaneously. But it's a cause and effect. The increase in current in the shunt field increases the magnetic field. The increase in the magnetic field increases your output voltage, and eventually you'll get to your rated voltage. Okay? What kind of questions we have here?
Yeah.